Today we are covering tokenization and embeddings. Turning text into vectors a model can compute with. The goal is not to memorize a slogan. The goal is to build an interview-ready explanation that moves from intuition, to mechanics, to trade-offs, and then to a concrete example. Intuition. Tokenization is like cutting a sentence into machine-readable puzzle pieces, then embeddings place each piece as a point in a learned meaning space. The model never sees words directly, it sees IDs and vectors. If you remember only one thing, remember the shape of the problem. Raw information is transformed into a representation that makes the next decision easier. Core mechanics. Text is split into tokens, words, word pieces, characters, or bytes. Each token maps to an integer ID from a fixed vocabulary. An embedding table turns IDs into dense vectors. Similar usage patterns can lead to nearby vector representations. Token choices affect cost, context length, multilingual behavior, and rare words. The compact mental model is text tokenizer. Token IDs embedding table vectors. Do not rush past the symbols. In an interview, define each part in plain language before you talk about implementation. That makes you sound like you understand the system, not like you only memorized notation. Common traps. Do not say embeddings are handwritten definitions, they are learned parameters. Do not assume tokens always equal words. Vocabulary design affix unknown, rare, and multilingual text. Long prompts are expensive partly because token count drives compute. Concrete example. The phrase playing might become one token, or it might become play plus ing. Those IDs look meaningless to us, but the embedding table turns them into vectors the transformer can process. Walk through the example slowly. Say what changes at each step, what stays fixed, and why the operation helps the model produce a better representation. Interview checklist. Define tokenization before embeddings. Explain IDs versus vectors. Mention learned embedding table. Use a tiny text example. Connect token count to cost and context limits. A strong final answer for tokenization and embeddings should have 4 beats. First, give the intuition. Second, name the components. Third, describe the formula or data flow. Fourth, mention the trade-off. If you can add one example, you will usually sound much more practical than someone who only gives a textbook definition. Now let us rehearse the answer in a more conversational way. Start broad. What problem are we solving? And why did this idea become useful in modern AI systems? Then narrow down, what data structure or tensor is being manipulated? Then explain the operation, what is multiplied, normalized, added, masked, or learned? Finally, connect it to behavior, faster training, better context, more stable gradients, lower memory cost, or clearer generalization. For interview practice, avoid 3 mistakes. Do not give only math without intuition. Do not give only intuition without naming the mechanism. And do not pretend there is no trade-off. Most AI interview questions are really trade-off questions wearing a concept label. The best answer shows you know when the method works, when it becomes expensive, and how engineers usually manage that cost. Quick recap: tokenization and embeddings. Turning text into vectors a model can compute with. Use the mental model, define the pieces, give the example, and close with the practical trade-off. That is the answer structure to keep in your head. One more interview rehearsal. Explain it as if teaching a teammate. Define the input, describe the transformation, name the output, and close with why the design choice matters in real systems. This habit turns a memorized answer into a practical engineering answer.